Okay, before we go on to subtracting polynomials, I forgot to mention when we were doing the adding polynomials here a minute ago about the fact that your book presents things in a couple different formats for you as far as whether you want to do these vertically or horizontally. I'm more of a horizontal setup type of guy where as long as I have them all there and I can just pick and choose and combine like terms, I'm okay. I don't really need to set it up vertically. But if vertical works better for you in that having them lined up one on top of another makes it easier to see that, that's fine. Just make sure that you're lining up like terms. Okay? It has to, you can only add x squareds together or x's together or x to the thirds together. So make sure that you line it up correctly if you're going to look at it vertically. For instance, here, the example number 2 on page, I think this is what, 112. It's one of those things where if you want to set it up that way, you can. You still need to go, and let me kind of bring up this. You still need to go through and distribute through the -1 first, regardless of what method you're going to use. Okay? I'm more of a horizontal guy. If I just bring down this 2 plus 9x squared, and then when I do -1 times -6x squared, I get a positive 6x squared, and -1 times -2 is positive 2x, -1 times -1 is -1. Whether you decide you want to do it that way, or you decide, you know what, I do kind of like this vertical thing, and you decide you want to do it this way, you still need to distribute through that -1 regardless. So that's going to be your first step, okay, to add the opposite, to change the signs. Now notice, this is the reason I don't like vertical sometimes, is because I have to leave this space here because my first part doesn't have an x term, and it's really easy to forget that sometimes and maybe add incorrectly. So that's why I'm not a huge fan of the vertical method. Doesn't mean you can't do it. Okay, for me, I'm more of a, okay, now that I have that distributed, where are my x squareds? Okay, I have 9 of those and then 6 more of those. Where are my x's? Okay, I just have 2x. And then where are my constants? I have a 2 up here and a -1 here. So those are my constants that I'm going to add together. That's just the way I see it, the way my brain works. That's just the way I am. Okay? So I have 15x squareds because I have 9 plus 6. I have the 2x that has nothing to combine with, and 2 minus 1 is 1. If you add these vertically, you're still going to get 15x squareds, and you're going to have the 2x, and then you still have 2 minus 1, which is 1. So either way, it's totally up to you which method which way you want to look at it. That just happens to be the way that I look at it. All right. Next example. One thing I did pick up from the book that I do like is the way that they phrase this. They use the phrase add the opposite. I know I've heard that before, but I don't really use that, but I kind of like that. Whenever you're doing subtraction, change it to adding and then add the opposite. So that means this. I can change this to plus as long as I change these to the opposite of what they started as. Adding the opposite. That's the same thing as distributing through the -1. All the same stuff will happen. But now you can, that quickly, you can just kind of change this to a plus in between, which we all know is much easier to deal with than the minus. Okay? It's the same thing as distributing through the -1. So it's not really changing anything, but I see it as kind of a shortcut. Now once again here, you can make the decision whether you want to use vertical or horizontal arrangement. I'm more of a horizontal arrangement person. You will see that they actually add an extra step where they, instead of just kind of highlighting the ones that are alike, they actually go as far as to rewrite it with those next to each other. I think that maybe is a little bit of overkill. You probably don't have to do that, but certainly if you see that as helpful, then go ahead and do that step. Okay, I'm not saying that you have to. I'm not saying you don't have to. It kind of just is up to you. So I'm not going to rewrite all these so they're next to each other. I can see which ones belong together. Positive 3x squareds plus a negative 8x squareds, that's going to take me down into the negative 5x squareds. 6x to the thirds plus a negative 4x to the thirds, that's going to be a positive 2x to the thirds. 2x's plus 2x's is 4x's. 9 plus a negative 5 is a 4. All different terms, cannot combine any, that's simplified. Okay, now there's one more of these that I want to just talk about, and that's the word problem that is on page, I guess it's 113. Okay? Now this is a long word problem. I'm going to give you a minute here to pause this and read through this first before I go on and talk. So right now, pause it, read through the whole thing. Okay, now that you've paused it and you've read through the whole thing, part A says make a plan. We have two different functions here. We have a function for the number of years since 2000. M of x are the male students. F of x are the female students. And what they want a model for all students. So I'm going to add those two functions together. I'm going to add the male function to the female function. So as we set this up here, this is what we have. We're going to add these together. Okay? So take a minute here, add these however you choose to do it, whether you want to write them out, however you want to do it, take a second and add these together. Okay, so this is what I got when I added all these together. I actually did add vertically this time, so double check yours and make sure it's the same as mine. The next thing we're asked to do here when we go back to the problem, once we've added these together, they want to know, estimate the total number of students in the year 2007. Well, up there on the fourth line down it says x is the number of years since 2000. So if we want to figure out the number of students in 2007, then we want to put 7 in for the x because it's 7 years since the year 2000. So here's where, in part C down here, you throw that in the calculator, you round to 1 decimal place. Take a minute, go back to this, and in this function here, we're going to evaluate it at t sub 7. So that means we're going to put a 7 here, and a 7 there, and a 7 there. Substitute in, multiply it out, see what you get. Okay, I got 17.082, and I know on the problem it said to estimate round to 1 decimal place, so we're at approximately, the function at 7 would be approximately 17.1, and remember the question is saying the total, so there were approximately how many students in 2007? That would be 17.1. I certainly hope I worked all that out right. Okay.